Okay, let's look at these now. We asked you to go through and identify what is oxidized and what is reduced. Now, if you went through the first one and identified sodium is a +1, oxidation number, oxygen's -2, hydrogen's +1. Hydrogen +1, nitrogen +5, oxygen -2. Sodium +1, nitrogen +5, oxygen -2, water +1, or not water, but hydrogen +1 in water, and oxygen -2. What changed? Nothing. Nothing increased, nothing was oxidized, nothing decreased, nothing was reduced. This is not redox, and you could have saved yourself all that work if you recognized this is double replacement. And double replacement chemistry is not redox. So all you had to do is look at that and say, that's double replacement, there's no redox going on. For the next one, we had copper solid is 0, chlorine gas is 0, both in their natural states. Copper 2 now is a +2 ion, and the chlorides are a -1. So the copper was oxidized. It is the reducing agent. And the chlorine was reduced. It gained an electron, had a decrease in oxidation number, was the oxidizing agent. Now, chlorine is a common oxidizing agent. Chlorine gas can be an oxidizing agent. Chlorine and the hypochlorite ion can be an oxidizing agent. We put sodium or calcium hypochlorite in swimming pools to kill bacteria and kill algae. And it does that killing through the power of chemistry of oxidation. It oxidizes things. That's how it kills the bacteria. It oxidizes it. Okay? You may have seen this at home. Anybody have chlorine bleach in their house? Sure, a lot of people do in the laundry room. Did you ever read the label where it says warning, danger, oxidizer? They put this warning label on there, but most people don't care because they don't know what that means, so they just toss it around. But oxidizers produce oxygen and they can support combustion. So if you have your chlorine bleach sitting near your hot water heater that has the little pilot light going, you can spill the chlorine bleach and it will support combustion and make your little pilot light turn into a big fire. Okay, this can be very, very dangerous, and people don't know this because they don't know what oxidizer means unless you're a chemist. And I know a few years back, quite a few years back, we put in above ground pool in our house. And, well, we didn't put it in the house, we put it in our backyard, all right? So we had the pool all set up, and we had the pool chemicals, and we're dumping tons of calcium hypochlorite in there, because that's the chlorine-containing species that we used in the pool. And then Bob took the bucket. We had these big white pucks that were calcium hypochlorite, and you put them in the skimmer, and they would dissolve and chlorinate the pool. So after he had put one in, he started to put them in the little shed in the backyard, and I said to him, don't do that. What do you mean? Don't do that. You're not my boss. Don't tell me what to do. This is how married people talk to each other, right? I'm like, don't do that. That's not safe. Because in the shed, we had 2 lawnmowers and a couple of cans of gasoline. And gasoline can warm up, get gas vapors in there. Then when you open the shed and throw a spark, you can have a fire. And having that oxidizer in there could be very dangerous. And he's like, you don't know what you're talking about. I'm like, actually, I do know what I'm talking about. I'm a chemist. Trust me on these things. So he wouldn't believe me, so I went in the woods behind our house, got some sticks, and I built a fire in the backyard. Just a little one. And I said, okay, now watch this. I took a hammer, broke up one of those big pucks, and I stood there tossing pieces of the puck into the fire. And it was just a little fire. I mean, I had like 5 or 6 little sticks in there, and it would just go whoosh and shoot up, flames 5 feet high. And I'm like, that is why you don't put that in there, because it can cause problems. So I separated them. Then he would put it back, and I would move it back to the garage. We went on like this for 20 years that we had the pool in the yard. But you have to be really careful about that, because if something goes bad, that can make it a whole lot worse. Yes?
So if you're trying to start a fire, you can
It would be really foolish and dangerous to start it that way. And there's a very good likelihood that you could end up visiting the burn unit at St. Mary's Hospital. You could be the patient of honor there. Everybody would come in to see that crazy guy who started fire with bleach. Yeah, it'll get a fire going for you. You don't want to do that. It's very, very dangerous for you because the potential for getting burned is really high. Okay, let's look at the next one. Anything unusual in the next one? It's double replacement. We trade partners. We make carbonic acid, which breaks down, and we make sodium hypochlorite. So this is double replacement. Nothing changes. There's no redox. You could go through and identify all of the oxidation numbers, but nothing changes. Okay, now let's look at this one. We went through and we got sulfur was a +2, oxygen -2, iodine 0, sulfur here +2.5. +2.5, can I have that? No. Sure, why not? For those of you that are sitting there looking at me like, huh? Why not? We know oxygen is a -2, so we get -12 equals -2, so I need 10. Divided by 4 is 2.5. A lot of my students are like, what's this, a half? You can't have a half. Sure you can, because this is an apparent charge. It's not a real charge. It's an apparent charge, so it's okay. Because it can appear that you're owning half electron if you're sharing it, okay? And iodide here is -1. So when we look, sulfur went from +2 to +2.5. So that's an increase. It is oxidized. It's the reducing agent. And iodine went from 0 to -1. That's a decrease in oxidation number. It was reduced. It is the oxidizing agent. It's a halogen, okay? We use chlorine in our pools. Sometimes we use bromine in our hot tubs. Why would you use bromine instead of chlorine in a hot tub? It costs more. Okay, anybody know why they put bromine in hot tubs instead of chlorine? It's gentler on your skin. Chlorine, the hypochlorite, is a really harsh oxidizer. You ever go in a swimming pool and your swimsuit bleaches out over the summer if you don't rinse it all the time, and you get your hair in there and your hair gets really dried out and brittle and your skin gets dried out? That hypochlorite is a really harsh oxidizer. Bromine is gentler, and in a hot tub, you're cranking up the temperature so the temperature can help with the killing power, and the bromine species aren't as hard on your skin, and usually the hot tub has lower traffic and things, so it works nicely. People use that in their home hot tubs. Okay, sometimes you can recognize redox by just recognizing these common oxidizing and reducing agents. Things that are oxidizers: oxygen, the halogens, nitric acid, dichromate ion, and permanganate ion. And reducing agents are hydrogen, metals, and carbon. So if you recognize those, it might be easier for you to recognize redox.